Hi everyone, my name is Taj Sahota and welcome to my poster. So anyone familiar with oncology drug development will know that the standard approach is to start off development by running a dose escalation study where you escalate based on safety, try to find a maximum tolerated dose, and then you essentially run with that dose or maybe slightly below that dose as long as you can up to marketing of the compound. Now, this is associated with lots of potential problems. That dose may not be the best in terms of risk-benefit, and also it may not pan out. There could be issues that crop up along the way. Nevertheless, this is still a pretty common practice in oncology, and it's how most drugs are still developed today. So this poster here is showing how we teamed up with statistics in AstraZeneca to convince our project team to run a dose-finding study to improve risk-benefit of the compound. The compound we were looking at in this case was savolitinib, and we were specifically looking to explore lower doses to improve risk-benefit, but the approach that we were using is general. So why use pharmacometrics? Because the use of more traditional endpoints like objective response rate are generally associated with needing much larger sample sizes. And in fact, in this case, our statistician calculated we would need 150 subjects per arm, which was too large to get an investment decision in this case. So what we did was we presented essentially what's in this poster to governance, which is a set of model-based power calculations looking to see the power associated with using pharmacometric endpoints based on longitudinal exposure tumor size modeling. We knew going into this that we would probably end up with higher power, but we didn't know whether it would be sufficient power for us to be able to get away with a smaller study size. Most of the poster centers around figure 2, that's the main results figure, and the headline result is that we have okay power with our approach. It's around 70% power at 25 subjects per arm at the lower dose level. And that was enough for governance. So this was the plot that convinced governance of the feasibility of the study. And the main result of all of this is that the study was performed and the results have been published already in the Lancet journal, and that's in the reference section for anyone else to read. But the focus of this poster here is more around the planning of that study and how we were able to get it off the ground. So one challenge we needed to overcome was to bring the team along with our approach. And so we showed them figure 1, which shows some example trial simulations. And here you can see that we are applying different penalties to the response associated with that lower dose level. And our goal was to figure out from the team what kind of a loss in response was too much. And they told us around 10 to 20% was too much. So there were other technical challenges to overcome, and those were that we needed to script and complete all the simulations described in the methods within a 2 to 3 week period. And the way I was able to script those was using a tool called NM Project. This is a script-based interface between non-mem and R that I have developed and is available in the reference section for people to find out more about. Overall, the goal here is to encourage this kind of practice in more oncology projects. So we had the advantage of being able to rely on a reasonable amount of historical data, and we could use that to construct very realistic trial simulations. If you're working on a project which is early stage, you're not going to be able to do that. And the consequence for you may be that if you're using a prior model to construct those trial simulations, it may not be realistic enough to guarantee that your calculated power levels are going to reflect your actual true levels of power. In that case, what I would recommend is that you put in an interim decision point into your study so that you can collect a few profiles worth of data, update your trial simulations and your power calculations, and then you've got the potential to amend your study if needed at that point. So that's it. Thanks for listening.